Hello and welcome and good morning. I am Vishwadeep. I welcome you all on Unacademy Computer Science channel. In this particular lecture, I am going to solve all those homework questions which I have given in my COA full length course. So many students were asking, sir, please give us solution of this question, this question, this question. I am giving solution of every single question which I have given in my YouTube channel full playlist. So all the questions will include from cache, memory, pipeline instruction, control unit, in fact IO organization, hard disk also, and in fact from the floating point representation also. So without any delay, let's start the session. Before we go further, let me introduce myself. My name is Vishwadeep and I work as a leader in Unacademy Computer Science channel under brands content sales team. I have written the GATE exam multiple times, 19, 119, 440, 682. There are few more ranks. I am went for my masters to ISE Bangalore, another masters from BITS Pilani. These are the courses which I am dealing with on Unacademy's platform. Apart from that, I have a rich experience of teaching only engineering students. If you guys want to learn for free, we have lots of opportunity for you all to learn for free on this channel, just because this channel provides you complete package for computer science, including your GATE preparation, semester exam preparation, including your placement preparation, including in fact machine learning and data science preparation also. So a complete solution you can have on this particular platform. But on this channel we teach you, yes, but we have lot content for you on Unacademy's platform also. Download the Unacademy app or go to unacademy.com. The Unacademy app should be a must-have app for you if you are a learner. Go and check out my profile. Once you go to my profile, you follow my profile, and under my profile you will be getting special classes. Those special classes are absolutely free. Monday to Friday, Saturday, Sunday, I am taking so many special classes. Tomorrow again I am having two special classes, one special class at 12 p.m, another special class at 3:30 p.m, and I'm going to teach you revision, some problems and lots of things in those special classes. Previously I have taken so many special classes. Those are also available on Unacademy's platform. Go and check out. If you are the first time user to unlock the free content on Unacademy's side, then you should use a particular code. This is the code. If you use this particular code, you will be able to get 10. Okay, you will be able to get what? The access of each and every free content, including free test series, quizzes, classes, and lots of other things. If you want to have all the special classes in organized manner, then you can go to this particular URL. This is the free test series we are running on Unacademy's platform. So go check out, enroll for that particular test series, and you will be getting lots of quality questions over there. If you are a serious candidate for GATE preparation, and if you want that you should have a really great preparation for yourself, then we have a really good opportunity for you, and that is Unacademy Plus platform. Unacademy Plus platform is that platform where you will be getting the classes structured schedule manner study, but more on that particular part you will be having a guided study in which we will decide how you will prepare for yourself. We as experts will decide that how your preparation should go, so that you can have your preparation going well. You won't have many doubts, you won't have any problem to search for the questions, test, quizzes, any kind of thing. So if you want to go for an Unacademy Plus subscription, in that you can have the live classes. Of course, you can listen all the live classes in the recorded mode also if you miss, or if you want multiple times. Then you can have weekly tests, you can have doubt solving, so many things you can get over there. And all these subscription, Unacademy Plus subscription, you can take in 1 month, 3 month, 6 month, 12 months, 18 months and 24 months package. All these subscriptions are available with discount if you use the code VDEEP10. This particular code will give you discount, plus this particular code will give you my mentorship. This particular code will give you a direct connection with your preparation to my team's effort. So if you want to connect with my team, then use this particular code, take the subscription and enjoy your best learning on Unacademy Plus platform. If you want that one personal coach you should get from Unacademy side who can give you preparation strategy time to time. If you want, you should get study planner. If you want, you should get study booster session. If you want that, you should get personalized test analysis, then you should go for iconic subscription. This iconic subscription has all the facility of Unacademy Plus extra facility of having personal coach who will give you preparation strategy, personalized study planner, customized planning you will be getting, study booster session, personalized test analysis you will be getting, preparation study material you will be getting. All these things come under iconic subscription. So if you want to have your rank to be iconic, go for iconic subscription and enjoy your best learning with a personal coach. And this particular subscription also comes using a discount if you use the code VDEEP10. Using the code, you will be having, or you will be paying less amount, plus you will be getting lots of other benefits, including my mentorship, including my team's efforts, team support and lots of other benefits. Look at this, we have our top educators with different batches so that you can have lot to learn from them. Now I want from your end is you should be ready for. So many students were asking sir इसका आंसर, उसका आंसर, इसका आंसर. आज सारे क्वेश्चन सॉल्व करेंगे, बट आपको थोड़ा सा सपोर्ट करना पड़ेगा. क्या सपोर्ट करना पड़ेगा? अरे लर्निंग के लिए रेडी तो हो जाओ. अगर आप रेडी हैं तो हम पढ़ेंगे. If you are ready, then we will go further. So type down in the comment box you are ready. If you haven't liked the video को like कर दीजिए. And other than that, if you have some other friends, share the link with all your friends so that they also can join and learn these questions. So many questions I have brought here, so all those questions we are going to solve along with you. You grab the paper pen, you also solve the question along with me, even ahead of me, and then let's see who solves the question first, me or you. Chaliye. So very first question is from microprogrammed control unit. What it says: consider a microprogrammed control unit which has to support 32 number of instructions. Fine. For each instruction execution, control unit generates a sequence of 64 control words. So total 32 instructions, and for each instruction a sequence of 64 control word means total how many control words control unit will have to store? These many. 32 instruction, for each instruction 64, second instruction 64, next instruction 64, such kind of 32 instruction for each 64 control words to be stored in the control memory of microprogrammed control unit. So total how many? 2 power 5 into 2 power 6, which is 2 power 11 control words to be stored. Fine. Each micro instruction contains 3 fields. Okay, so let's go with the micro instruction fields. This is the micro instruction and it has 3 fields. What are the 3 fields? 118 control signals to support horizontal control unit. You remember horizontal control unit means 1 bit for each signal. So if 118 signals, then for the control signals we will be having 118 bits. Right? Got it? Fine. Now next. A mux select field to select one of the 8 inputs. So we have a mux select field. If we are selecting among 8 inputs, can you tell me how many bits are required for selection? 3 bits are required for selection. 3. and another one at next address field. Okay, fine. So there will be another field which is address field. Now the question is, how can I understand that what is the address size? Look at this. We will understand the first two lines again, that we have a control unit in which 2 power 11 different control words I am storing. How many? 2 power 11 different control words I am storing. And why it is needed? To support 32 instruction, each instruction 64 control word. So total how many control words I'll have to store? 2 power 11. Based on that, can I say that the addressing of this particular memory will be of 11 bits? Yes of course. Yes of course. So 11 बिट का एड्रेस हो जाएगा. टोटल एक माइक्रो इंस्ट्रक्शन का लेंथ बताएं कितना होगा? द माइक्रो इंस्ट्रक्शन लेंथ विल बी 118 प्लस 14. 118 प्लस 14 कितना हो जाएगा टोटल? दिस इज 132 बिट्स, right? So look at this. I can understand it like that way. 2 power 11 different micro instructions I am storing, and each micro instruction size is 132 bits. So control memory size will be how much? Control memory size will be how much? जल्दी से बताएं, कंट्रोल मेमोरी का साइज क्या होगा? Control memory is equal to total 2 power 11 into 132 bits. Is that fine? Can I say 264 kilobits? How can I say? 2 power 1 is 2. 132 into 2, 264. 2 power 10 is kilobits. If they ask the answer in kilobytes, divide this by 8 and you will get the answer. समझा? नहीं समझा? समझेगा? Got it? So 132 bits was one particular micro instruction size. Entire memory size will be 2 power 11 different micro instructions, each of 132 bits. This is my answer. If you divide this by 8, you will be getting what? Kilobytes. Let's do that. 8 से divide करो. 33 kilobytes can be the answer. Can you verify 33 is correct or not? Divide 264 by 8. Will you get 33 kilobytes or not? Can you please verify? Next question. Let's go for the next question. Design of a vertical microprogrammed control unit requires to generate 40 signals. Fine. Out of 35, those only 3 signals can be active at a time. Okay. Out of 40, 35 में से 35 में से सिर्फ 3 सिग्नल ही एट ए टाइम एक्टिव हो सकते हैं, एंड फॉर रिमेनिंग 5 एनीवन कैन बी एक्टिव एट ए टाइम. सो द थिंग इज अगर हम वर्टिकल माइक्रो प्रोग्राम की बात करते हैं, वी कैन हैव द ग्रुप्स, राइट? सो व्हाट दे आर सेइंग, among starting 35 signals, among those maximum 3 signals can be active. If we have that particular constraint that only maximum 3 signals can be active, then 35 signals we can keep in 3 groups. But do we keep 35 signals in mutual exclusive group? No. Why? Just because I don't know among 35 signals what signal to be enabled from one group and which signal to be enabled from another group. Any signal can be enabled. 35 में से कोई भी सिग्नल कभी भी enable हो सकता है, कोई भी 3 सिग्नल enable हो सकते हैं. Yes. So what we will do is we will of course make 3 groups. Group number 1, group number 2, group number 3, but we will keep all 35 signals in all 3 groups, so that among 35 one signal can be enabled from this group, one signal can be enabled from this group, one signal can be enabled from this group. Now further, now what they are saying is for remaining 5 anyone can be active. मतलब 5 में से कोई भी कभी भी एक्टिव हो सकता है. Can we now make a group of those 5 signals? No. If one signal is enabled, I don't know. 2 signal enabled, I don't know. 3 signal, all 5 signal can be enabled at a time. So what we will keep is, we will keep those 5 signals in horizontal way. We will keep those 5 signals in horizontal manner. So this particular question is actually they are asking us to have the vertical microprogrammed control unit, but we need to use some signals to be stored in horizontal manner also. The microinstruction of control unit stores control signal information along with 3-bit mux select. So mux select I am having, that is of 3-bit, and further 12-bit address field. Okay, fine, let's extend this, and here it is address field of 12 bits. The size of control memory required is, look at this, if this is a group having 30 question, if you want to have the answer in kilobits, multiply 2 power 2, which is 4 into 38, that will be kilobits. If you want to have the answer in kilobyte, divide this entire thing, divide by 8, and you will be getting kilobytes also. So it will be 19 kilobytes. Got it? समझ पा रहे हो? These all are the question which I have given you for solving. If you have solved priorly, that's well and good. If not, then let's just see why I am solving these questions like that way, how I am solving those questions. Another question. Next one, which is from IO organization. An asynchronous serial communication is employing 8 character bits, 1 parity bit, 2 start bit, and 1 stop bit. Tell me, for one character how many bits are there? For one character how many bits I am transmitting? 8 character bits plus 1 parity bit, 2 start bit, and 1 stop bit. Total 12 bits. Fine. To maintain a rate of 500 characters per second, such kind of 500 characters I want to transfer. 500 characters I want to transfer. Then, if 500 characters I want to transfer, then what should be the transfer rate? What should be the transfer rate for the communication in bits per second? In bits per second. Now look at this. I want to transfer 500 characters per second. 500 कैरेक्टर भेजने के लिए एक एक कैरेक्टर 12 बिट का होना चाहिए. So how many bits per second I'll have to transfer for 500 characters? I will have to transfer 12 bit per transfer or per character into 500. 6000 bits per second. Can you verify? Can you verify? Can you verify? 12 into 500, 6000 bits per second I will have to transfer. Is that clear? Is that clear? Is that clear? Next one. Another question of the same asynchronous transmission. An asynchronous serial transmission S1 uses 8 characters bits, 1 start bit, 1 stop bit, and a parity bit. Fine. A synchronous transmission S2. So we have different 2 types of transmissions, S1 and S2. Fine. So S1 says what? It's a asynchronous type. So it is sending for one character. For one character it is sending 8 character bits plus 1 start bit plus 1 stop bit, yes, and a parity bit. Total how many bits? 11 bits. A synchronous transmission S2 uses two 8-bit synchronous characters followed by 25 8-bit information characters. So this is saying synchronous serial transmission says for each and every character you are sending one start, one stop and one parity bit. हर एक कैरेक्टर के साथ में आपको 3 बिट्स भेजना ही भेजना है. But here I am saying for a synchronous transmission, for every 25 characters of 8 bits each, you are sending only 2 8-bit characters. Means for 25 characters, for 25 characters, how many bits you are sending? How many bits you are sending? 2 into 8 plus 25 into 8. 216 bits you are sending for 25 कैरेक्टर्स. अभी नहीं समझ में आया सर, क्या हो रहा है? नहीं समझ में आया. देखिए सिंपल सा कंसेप्ट है. S1 ट्रांसमिशन बोलता है हर 8 बिट के कैरेक्टर के साथ में आपको सिंक्रोनाइजेशन बिट्स भेजनी है. हर एक कैरेक्टर के साथ, एक कैरेक्टर के साथ कुछ एक्स्ट्रा गार्ड बिट्स जाएंगी. ये देखो, वन एक स्टार्ट बिट, वन स्टॉप बिट और एक पैरिटी बिट. यहां पे ऐसा बोलते हैं कि एक काम करो, जैसा आप टीसीपी/आईपी प्रोटोकॉल में करते हैं ना कि पहले एक हेडर अटैच कर दिया, उसके बाद फिर बल्क में डेटा अटैच करते हो, एक पैकेज या एक पैकेट अटैच करते हो, वैसा ही ये सिंक्रोनस ट्रांसमिशन बोलता है. ये क्या बोलता है? व्हाट इट सेज कि आप एक काम करो, पहले 2 8 बिट के कैरेक्टर भेज दो फॉर सिंक्रोनाइजेशन, उसके बाद फिर 25 8 बिट के कैरेक्टर्स भेजो इंफॉर्मेशन के नॉन स्टॉप विदाउट सेंडिंग एनी एक्स्ट्रा इंफॉर्मेशन. तो आपने पहले एक हेडर भेज दिया 16 बिट का, ये भेजा, देखो ये रहा, और उसके बाद आपने 25 कैरेक्टर्स भेजे 8 बिट के, और वो भी नॉन स्टॉप कंटिन्यूअस, क्योंकि ये सिंक्रोनस टाइप का ट्रांसमिशन है. अब देखते हैं टोटल आपने 216, यू हैव सेंट 216 बिट्स फॉर 25 कैरेक्टर्स. फॉर 25 कैरेक्टर्स दीज मेनी, देन फॉर वन कैरेक्टर हाउ मेनी? एक कैरेक्टर के लिए कितना? 216 डिवाइड बाय 25. Can somebody solve this particular thing for me? 216 divided by 25, you will be getting answer 8.64. 8.64 bits per character. Now the question is, if the transfer rate is 1500 bits per second, you can send only 1500 bits per second. So how many characters per second you can transfer? So if you can transfer 1500 bits in a second of 1111 bits, how many characters you can transfer? Answer will be, for the rate here 1500 divided by 11, and here 1500 divided by 8.64. Those characters per second you will be transferring. Okay, so let me calculate it for you. 1500 divided by 11, you will be getting 136.36 characters per second you can transmit here. But here of course it will be more. 1500 divided by 8.64, you will be getting 173.611 characters per second. These are the two different transmission schemes given, and based on that we have calculated that what will be our transmission rate or transfer rate in terms of characters per second. I hope you got the same thing. Okay, now here, look at this next question. This particular next question is again from IO organization. Now again IO organization, what it is about program control mode or programmed IO. Let's see what the question is. Consider a device which operates with 20 kilobyte per second. 20 kilobyte per second operating speed, so that device can process the content in this speed. The device is operating on program control mode. If you remember program control mode of IO or programmed IO, very simple it is. If you don't remember, let me recall you again the same thing, that programmed IO is that particular IO organization in which the CPU will send some kind of signal to IO operation or IO device that if you have something to transfer the data, give me your status, then I will give you, or I will have the transfer with you. So first of all, CPU will check the status of each and every device, and after that, if device has the status set, then device will transfer the data. Yes, correct. Now the thing is, question is what? It has to transfer the data 100 bytes. Fine. The data is transferred byte-wise. So one by one byte you need to transfer. Size of status register is 2 byte. Okay. So now the scenario is like this. First of all, CPU will check the IO device's status by reading 2 bytes from the device. Okay. Of course, 2 byte read time will be based on this speed. After that, the device will transfer these 100 bytes, and 100 bytes also will be transferred byte by byte using this particular speed only. Total time needed to perform the data transfer is how many microseconds? So first of all, let's try to calculate the 1 byte transfer time using this particular speed. The device operates with this speed will take how much time to send these 2 byte ka status, or 1 byte at least we can calculate 1 byte transfer time is how much. So let's check it out. For 20 kilobyte transfer, the device takes how much time? 1 second. If that is the case, then for 1 byte transfer, the device takes how much time? 1 second divided by 20 kilo. Right? Now this kilo goes up, becomes minus 10 to the power minus 3, means millisecond. 1 divided by 20. Let me take it as like this way, 1000 divided by 20. So multiply and divide by 1000. So if I'll divide by 1000, here also 10 to the power 3 added means mega it becomes, and when mega goes up becomes microsecond. How much it will be? जल्दी से बताओ. 1000 divided by 20 will be what? नहीं समझ में आया? 50 microsecond. 50 microsecond for 1 byte transfer. Now total time will be how much? Look at this. Total time will be equal to time to check status plus 100 byte transfer time. Now you only tell me, आप ही बताओ, time to check status will be how much? 2 byte का status register transfer time. 2 byte transfer time using this. So 2 byte transfer time means 2 into 50 microseconds plus 100 byte transfer time will be 100 into 50 microsecond. How much it will be? 100 plus 5100 microsecond. Can you verify? Is the correct answer? Is this a correct answer? Can you verify quickly? जल्दी से आप verify कर दीजिए if this is the correct answer or not. 100 from here, 15 to 100, which is 5100 microsecond is the answer. So you need to understand the requirement of the question, and based on that you need to answer it. Okay, chali. Now next question. Consider a CPU which takes 6 microseconds as interrupt overhead time. What is the meaning of interrupt overhead time? Interrupt overhead time is nothing but when CPU receives an interrupt, after that CPU takes a little bit time to start the service. Why? Just because CPU will have to understand that who has sent the interrupt, should I accept it or not? If I am accepting, then what is the priority of interrupt? Should I go directly to the interrupt service or should I execute the default service routine? There are so many things: priority resolution, then getting the starting address of the service routine, and lots of other small things CPU will have to perform, and for that overhead time is taken, which is 6 microsecond. So that 6 microsecond is before starting of the service. After that, what it says? When a CPU device generates interrupt for CPU and CPU accepts it. तो जब CPU accept करेगा किसको? interrupt को, तब 6 microsecond CPU लेगा. After that CPU takes 7 cycle to service the interrupt. इसके बाद लगेगा 7 cycle सर्विस को interrupt करने के लिए या interrupt को सर्विस करने के लिए. Okay, if CPU runs on 10 megahertz clock rate, then total time CPU spends for interrupt service is अभी 7 साइकिल्स दे रखी हैं. ठीक है, तो मेरा जो पूरा आंसर होगा ऑल दोज मेंबर्स जो लेट ज्वाइन किए हैं हमें, वेलकम एवरीबॉडी. इफ यू हैवंट लाइक द वीडियो, प्लीज लाइक कर दो वीडियो को और क्वेश्चन साथ में सॉल्व करो मेरे. आपको भी मजा आएगा, मुझे भी मजा आएगा, जस्ट बिकॉज व्हेन यू विल बी हैविंग इंटरैक्टिव स्टडी, डेफिनेटली वी विल एंजॉय. इफ एनीबॉडी हैविंग एनी क्वेरी, क्वेश्चन और डाउट, कोई अनआंसर्ड क्वेश्चन रह जाता है, देन वी विल डेफिनेटली टेक दोज unanswered question either at the end of the session or in some special classes on Unacademy, but definitely I will clarify all the doubts. Consider a CPU which takes 6 microsecond for interrupt overhead and 7 cycle for service. So total time will be how much? Total time will be equal to, पहले तो लगेगा ओवरहेड का टाइम प्लस लगेगा सर्विस का टाइम. अभी ओवरहेड टाइम इज डायरेक्टली गिवन, यस, विच इज 6 माइक्रोसेकेंड. फाइन, 6 माइक्रोसेकेंड. Is the service time given directly? No, it is given as 7 cycle and 1 cycle time is 10 megahertz. So let's calculate 1 cycle time from here. एक साइकिल का टाइम कितना होगा? एक साइकिल का टाइम होगा 1 डिवाइड बाय क्लॉक रेट which is 10 megahertz. It becomes how much? 0.7 microseconds, right? Sorry, 0.1 microsecond. 0.1 microsecond. 1 by 10 is 0.1 microsecond. Okay, so cycle time is 0.1 microsecond. Fine. Ab 0.1 microsecond is cycle time. Such kind of 7 cycles are required for the service. Total is 6.7 microsecond is the total time. Got it? Understood that? If you understood that, keep writing yes, no, anything so that I can understand that you are understanding. समझना जरूरी है. नेक्स्ट क्वेश्चन ये देखिए, अगला प्रश्न ये रहा आपके सामने. देखते हैं. कंसीडर अ डिवाइस ऑपरेटिंग ऑन 8 मेगाबाइट पर सेकेंड स्पीड एंड ट्रांसफरिंग द डेटा टू मेमोरी यूजिंग साइकिल स्टीलिंग मोड ऑफ टीएमए. ओहो, साइकिल स्टीलिंग मोड. सर भूल भुला गए सब, तो याद रखो सब. इफ यू डोंट रिमेंबर, टुडे आई एम गोइंग टू हैव pipeline, or not today, tomorrow Monday I am having pipeline revision and next day I am having Tuesday IO organization revision on special classes, Unacademy special classes for free. वहां आओ, ज्वाइन करो मुझे, and then we will solve the questions also. We will see the theoretical topics also, and every single thing we will have over there, and you will be having opportunity, golden opportunity to ask so many questions to me. You can ask any question. Very interactive study, very interactive discussion we'll be having. Let's see what this question says. Operating on 8 Mbps speed, transferring the data to memory using cycle stealing mode. If it takes 250 nanoseconds to transfer 16 bytes data to memory, then when it is ready or prepared, then percentage of CPU blocked due to DMAs. This is the time to transmit the data from IO device to memory. How much data? 16 byte ka data, but how much time that device will take to prepare this 16 byte ka data using this speed? Let's calculate that. Let's calculate that. So I will write it like this way, ki the device 8 megabytes data prepared by device. 8 megabyte data prepared by device in how much time? In the time is equal to how much time? 1 second. Then 1 byte ka data prepared by the device in how much time? 1 divided by 8 mega means 1 by 8 microsecond. And more on that particular thing, let's calculate that if 1 byte का data, but मुझे 1 byte का data एक बार में नहीं send करना है. The data size is 16 byte. So 16 byte data is prepared by the device in how much time? It is 16 into 1 divided by 8 microsecond, which is 2 microsecond. As we know that this particular thing is given in nanosecond, either you convert this in microsecond or you take this as nanosecond. Microsecond ko nanosecond mein convert kar lo, that will be better. 2 microsecond means I can say 2000 nanoseconds. 2000 nanoseconds. Fine. Now, if 2000 nanosecond is the preparation time, transmission time is 250 nanoseconds, then what is the percentage of time CPU is blocked in DMA? So, percentage of time CPU is blocked is only when the data is being transferred to memory, which is 250 nanosecond, among time 2000 nanoseconds, percentage, that's why into 1000%, है ना. 1000 लिखेंगे, 100 लिखेंगे. अरे जागो रे बाबा, जागो मोहन प्यारे, उठ जाओ, चाय शाय पी लो, आराम से मुंह धो लो और अब अच्छे से पढ़ाई करो. This is the time you engineers, including me, we get up only when the exam date comes. That's the regular routine of every semester. So please wake up now. Exam dates are there. So 250 divided by 2000. How much it is? 250 divided by 2000. How much percentage? How much percentage? How much percentage? 25 by 2. 25 by 2 is how much? 12.5% of the time the CPU will be blocked due to DMA. चलें आगे बढ़े. Next question. Next question. Here it is. Next question. Next question. Here it is. See, a device is constantly transferring the data with 40 kbps speed to memory using DMA. Fine. Assume that the transmission time to memory from IO once the byte is 1 byte data is ready is 10 microsecond. Fine. Further assume that a file of 20 kb needs to be transferred to memory. Okay. Percentage of time CPU is blocked due to DMA in burst mode. Percentage of time CPU is blocked. Okay. 9 die 2. गलत टाइप हो गया थोड़ा सा. Due to DMA in cycle stealing mode is how much? Only difference between cycle stealing mode and burst mode is the formula. Here in the cycle stealing mode we write that transmission time divided by preparation time into 100%. In the burst mode we will write Transmission time divide by addition of transmission plus preparation time into 100%. That's it. Other than that, nothing different. Let's solve this particular question. First of all, let's try to understand what is the speed and what is the data size. 1 byte data size. 1 byte data size. Fine. Okay. Now 40 kbps का speed. 40 kbps का speed. So 40 kilobytes can be transferred using how much time? In how much time? Transferred in the time is equal to 1 second. Then 1 byte data can be transferred by the device in how much time? 1 divided by 40 kilo or 1000 divided by 40 microsecond. How much it is? 25 microsecond. 25 microsecond. 25 microsecond. Fine. Now further. Once the data is ready, 10 microsecond is required for transmission. Look at this. Look at this. If you will calculate for burst mode, I am talking about. अगर आप burst mode के लिए calculate करेंगे for 20 kilobyte, how much time is to prepare? You will multiply it by 20 kilobyte, and then you will multiply this also by 20 kilobyte. You will get same answer as 1 kilobyte also or 1 byte also. तो आपको multiply करने की जरूरत नहीं है. Here it is the time saving particular tip I am giving you. You don't have to calculate total time कितना लग रहा है इस फाइल को ट्रांसफर करने के लिए. 1 byte, if you know for 1 byte how much time is saved or blocked or whatever, then for 20 kilobyte also same to same. Just because everything comes in cycle. एक byte by byte ही transfer होगा. That's why. So if first thing I am asking you, if I am first thing going for percentage of time CPU blocked in DMA burst mode, for burst mode percentage of time CPU is blocked, that will be formula same to same रहेगा. बस याद रखें formula different है, same to same. 10 microsecond for transfer divide by 10 plus 25 into 100%. Can you calculate how much it is? कोई calculate कर सकता है कितना होगा ये? 10 divide by 35, you'll be having 28.57%. इफ यू वांट, नहीं सर ये तो गलत है, हमको 20 किलोबाइट ट्रांसफर करना है. 20 किलोबाइट ट्रांसफर करने के लिए कितना टाइम लगेगा ये कैलकुलेट करो. सो व्हाट यू विल डू, यू विल मल्टीप्लाई हियर 20 किलोबाइट का ट्रांसफर टाइम, एंड यू विल मल्टीप्लाई हियर आल्सो इन 10 माइक्रोसेकंड आल्सो 20 किलोबाइट. हियर 20 किलोबाइट का मल्टीप्लाई, हियर आल्सो 20 and here also multiplication. This multiplication I'll take as common and from here also common and it will cross. तो अल्टीमेटली आपको आंसर 28.57 ही आएगा. अल्टीमेटली यू विल गेट सेम आंसर. आप चाहें तो मल्टीप्लीकेशन करके देख सकते हैं. सेकेंड वन, साइकिल स्टीलिंग. वेरी गुड मॉर्निंग, वेरी गुड मॉर्निंग. आई होप यू ऑल आर फाइन. साइकिल स्टीलिंग मोड. साइकिल स्टीलिंग मोड का फॉर्मूला क्या होगा? साइकिल स्टीलिंग मोड में percentage of time CPU blocked is transfer time 10 divided by the preparation time 25 into 100%. कितना हो जाएगा? जल्दी से बता रहे बाबा, जल्दी से बता रहे बाबा, कितना percentage of time CPU is blocked? Can you tell me? Can you tell me? Can you tell me? Can you tell me? No, 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 no. Hurry, no, no, no. How much percentage of CPU blocked If you are dividing here by larger value, you'll be getting lesser value. Yes, he'll be dividing. यहाँ 28 से तो कम ही आना चाहिए. Yes, 40%. Good, 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 good. Nice. 40%. Yes, 40%. Yes, correct. Yes. Okay. चलिए next question. That particular question is of memory organization. So IO organization control unit questions we have already solved. Let's go for the next one. Memory organization. Consider a CPU which has 12-bit address bus, 16-bit data bus, maximum size memory which can be supported. If address is of 12 bits, you will be having total 2 power 12 number of addresses in the memory. On each address you can store 16-bit of data. So this is the memory. Question is asked in किलोबाइट्स. इसको बाइट में कन्वर्ट करो. डिवाइड बाय 2, so it is 2 power 12 into, sorry, divide by 8, it becomes 2 bytes. So it is 2 power 13, which is 8 kilobytes. Answer is 8. मुझे लगता है इस क्वेश्चन का आंसर तो आपसे बन गया होगा. हाँ, नहीं, yes, got it. Okay, another question. A 32 bits wide memory has 22 bits addresses. अब इसका मतलब क्या है 32 bit wide memory? 32 bit wide memory means on each address 32 bits can be stored. On each address 32 bits can be stored, and such kind of 2 power 22 bits are there. Maximum memory capacity is how much? If addresses 2 power 22 bits addresses we have, then number of addresses will be having 2 power 22 cross 32 bits on each address. The meaning of 32-bit wide memory is on each address CPU will expect that I should get 32 bits का data. Simple. So 2 power 22 into 32 bytes में पूछा है. Capital B is bytes. So convert this into bytes. 32 bits is 4 bytes. So it becomes 2 power 2 into 2 power 2, 2 power 4, 16 मेगा बाइट्स. ये मेगा कहां से आया? ये मेगा आया बरसोरे मेगा वाला नहीं है यहाँ. Okay, so this 2 power 20 is mega. That's why answer is 16 megabytes. Good, nice, Anvesha, super, amazing. You need to solve these questions along with me, then only you will enjoy. Okay, another question. A memory cycle time of a memory is 500 nanoseconds. The maximum rate at which memory can be accessed. Cycle time दे रखा है, rate पूछा है. आप बचपन से अपने जब से फिजिक्स पढ़ा है, मैथमेटिक्स पढ़ा है, तब से आप ये करते आ रहे हैं. हाउ टू कन्वर्ट टाइम इनटू फ्रीक्वेंसी और रेट. वेरी सिंपल. द रेट विद विच, मैक्सिमम रेट विद विच द राइट ऑपरेशन और रीड ऑपरेशन कैन बी परफॉर्म्ड इन द मेमोरी इज दिस. Nanosecond will go up, becomes 10 to the power 9 divided by 500 per second. If memory is byte addressable, that means these many bytes per second can be accessed. If you want, you can take 1000 apart from here. So it will be 1000 divided by 502 into 10 to the power 6, which is megabytes per second. 2 megabyte per second. C option is correct. बोलो भाई बोलो, समझता कि नहीं समझता? नेक्स्ट वन, अनदर क्वेश्चन, वेरी सिंपल क्वेश्चन. दीज आर द अमाउंट ऑफ रोम नीडेड टू स्टोर द टेबल फॉर मल्टीप्लीकेशन ऑफ 2 8-bit unsigned integers. Okay, so let's see here. Look at this. If you have to store a table of multiplication and you have 8-bit input, it's very simple. If you have 8-bit input, each result of multiplication will be 8 plus 8, 16 bits का. 16 bits each result will be stored. And such kind of how many results you are going to store in the memory. First of all, 8 bit के दो integers, two integers of 8 bits each. You need to store an entire table, means you need to store each combination of 8 bit multiply by each combination of 8 bits, means you need to store 2 power 8 into 2 power 8, total 2 power 16, such kind of results. So what will be the size of memory required? Size of memory required is 2 power 16 number of results, और हर एक result का size है 16 bits का. Now, if the question they are asking the answer in kilobyte, megabyte, kilobits, megabits, whatever, you can convert this. You can convert this. So let's convert this in megabytes, bytes. So this is 2 bytes. It becomes 2 power 16 into 2 bytes. Based on that, 2 power 17 it becomes, and which is 128 kilobytes. Or in fact you can write it as this also 1 megabits. Fine, got it? See, it's very simple. Bytes or bits, whatever the option given, based on that you can give the answer to them. Okay, you can give the answer based on they are asking bits or bytes to you. Fine, चलिए आगे बढ़ते हैं. The amount of ROM needed to store the table for addition of two 8-bit unsigned integer. Oh, अब आंसर थोड़ा अलग आएगा. Now they are asking us to store the addition table. अब सर एडिशन और मल्टीप्लिकेशन में क्या डिफरेंस है? ये तो मैं आपसे पूछता हूं, आप बताओ एडिशन और मल्टीप्लिकेशन में क्या डिफरेंस है, पता है ना आपको? नाउ लिसन, इफ यू हैव टू 8-bit values and their addition, then each result of 8-bit value addition will be of just 9 bits. दो 8-bit वैल्यू का अगर एडिशन करोगे तो आंसर आएगा 9 बिट्स में. तो रिजल्ट इज ऑफ 9 बिट्स. नाउ व्हाट यू नीड टू स्टोर इज अ टेबल. टेबल शुड हैव 2 8 bits values addition, which means I need to store each 8-bit combination plus each 8-bit combination. How many results? How many such results I'll have to store? Number of results I'll have to store is 2 power 8 into 2 power 8. समझ पा रहे हो कि नहीं कि ठंडी ज्यादा है कर रहे हो? यहां से थोड़ा सा दिमाग लगाएं, थोड़ा सा इच्छा जागृत करें कि हाँ सर पढ़ना चाहते हैं, समझना चाहते हैं, डेफिनेटली मजा आएगा. सॉल्व भी करोगे आप मेरे साथ में तो और ज्यादा मजा आएगा. सिर्फ सुनोगे एक कथा भागवत की तरह या जस्ट एक लेक्चर की तरह तो मजा नहीं आएगा. लर्निंग तभी है जब वो इंटरैक्टिव हो. ओके फाइन. अभी सिंपल सी बात है, ये सिंपल सा एडिशन का रूल होता है कि व्हेन यू ऐड टू वैल्यूज ऑफ 8 बिट्स देन द रिजल्ट ऑफ एडिशन कैन बी मैक्सिमम ऑफ 9 बिट्स. ये आप डिजिटल लॉजिक में सीख जाओगे. नाउ इफ आई वांट टू स्टोर अ टेबल में क्या स्टोर करेंगे? आई हैव टू स्टोर ईच 8-bit कॉम्बिनेशन का एडिशन विद ईच 8-bit कॉम्बिनेशन. मतलब 0 plus 0, then 0 plus 1, 0 plus 2, 0 plus 3, up to 0 plus 255. Then 1 plus 0 to 255, 2 plus 0 to 255, 3 plus 0 to 255. Similarly up to 255 plus 0 to 255 plus 255. इतना स्टोर करना है आपको. एंड सो मेनी रिजल्ट्स. हाउ मेनी? 2 power 8 into 2 power 8, टोटल 2 power 16 रिजल्ट्स, और हर एक रिजल्ट का साइज 9 बिट्स का. 2 power 16 cross 9 bits. Kilobit, kilobyte, whatever you want, you can convert this. Got it? चलिए आगे बढ़ते हैं. नाउ आई एम लीविंग आंसर ऑन यू. व्हाई? जस्ट बिकॉज बेस्ड ऑन द ऑप्शंस यू विल हैव टू चूज, बेस्ड ऑन द यूनिट you will have to choose how to solve this particular question further. You can convert this into kilobits also, you can convert this into kilobytes also. Okay, another question which is really easy again. A 64-bit wide main memory. I told you 64-byte memory matlab kya? On each address CPU expects that what? The memory should store 64-bit ka content. Means this memory is word addressable memory. Whenever CPU generates an address, memory will give me 64 bits, which is nothing but 8 bytes. Check. With a capacity of 4 gigabyte, fine, is built using this RAM chip. How many chips are required to construct such memory and how they are arranged? First of all, if one address is storing 64 bits, 64 bit is nothing but how many bytes? How many bytes? Kitna byte? 8 byte ki 6 bytes? 8 bytes. So on each address CPU expects 8 byte ka content. Now how will I understand my memory? As I will understand the memory is arranged like this way ki so many addresses are there in the memory. I don't know how many, but on each address I will be able to store 8 byte ka content. That is my visualization. So my memory is some number of addresses cross 8 bytes is equal to total capacity 4 GB. So can you tell me how many such kind of number of words I can have so that total capacity I can get 4 GB? Number of words in my memory of 8 bytes each is equal to 4 GB divided by 8 byte. यहां से number of words निकाल लेंगे. How much it will be? 2 power 29 words. I hope you will understand these conversations or conversions. 4 is 2 power 2, G is 2 power 30. So 2 power 32 divided by 2 power 8, which is 2 power 29 words. 2 power 29 words. So here I have filled this particular 2 power 29 words. Each word 8 byte is 4 GB. So my memory I will represent like this. The memory I am having in my computer system, the requirement is like this: 2 power 29 words, each word is of 8 bytes. But this particular memory chip we don't have. We have a chip of this. So using such kind of chips, how many number of chips required so that I can construct such kind of memory? Number of chips will be equal to how many? Number of chips is equal to 1/4 of amount of air we have in the Lay's packet. सुबह सुबह तुमको लेस की याद दिला दी. I don't know what about you, I don't know about you, but मुझे सबसे अच्छा ग्रीन पैकेट ही लगता है. What about you? The green lace is best. No? चलिए. So 128m is 2 power 27. 2 power 29 divided by 2 power 27 is 2 power 2, which is 4 cross. यहाँ पे है bytes, यहाँ पे है bits. So byte will become 64 bits divided by 8 bits. Answer is 8. So 4 into 8, total 32 chips are needed, and these 32 chips are arranged in what arrangement? What organization? This. You will be having 8 such chips in one horizontal arrangement, and such kind of 4 horizontal arrangements are arranged vertically. Such kind of chip will be required, or chip organization required. 8 chips. Hope you got that. चलिए आगे बढ़ते हैं. Another question. Let's see. same question which I told just now. In above question there are x horizontal arrangement of the chips with y number of chips in each arrangement. So how many horizontal arrangement are arranged in vertically manner? 1 2 3 4. In each horizontal manner how many chips are arranged? 8. So x horizontal arrangement means x is equal to 4. Y number of chips in each horizontal arrangement, y is equal to 8. The total value of 10x plus y is how much? 48. 48. Good. Nice. Super people. Super. बहुत बढ़िया. बहुत ही शानदार. बढ़े आगे. अगला क्वेश्चन देखें. नेक्स्ट क्वेश्चन शुड वी गो फॉर और नॉट? Another question. Here it is. Very simple. Once again, a computer system has a cache with access time TC 10 nanosecond, hit rate 80%, and average memory access time TM is 20 nanosecond. Average memory access time it is, okay. The access time for physical memory nothing but main memory. How much? Main memory access time not given. First of all, memory's access time is given. Yes, cache memory, main memory. Yes. So first check is done. Yes, access times are given. So now we need to choose simultaneous or hierarchical. Is there any mention in this particular question of word level or hierarchy? No. So we need to go with the simultaneous access. Let's go with the simultaneous access. साइमल्टेनियस एक्सेस लिया, फॉर्मूला लगा दो. एवरेज मेमोरी एक्सेस टाइम TM 20 nanosecond is equal to when there is a hit cache memory's access time plus when there is a miss main memory's access time TP. कितना होगा ये? 8 12 TP is equal to 12 divided by 0.2 which is 60 nanosecond. Oh, बल्ले आ गया आंसर 60. ग्रेट, अमेजिंग, सुपर. अनदर क्वेश्चन. बहुत आसान से क्वेश्चन दिए थे मैंने so that you can have a good practice over the questions. Look at this. What hit rate is required for cache to reduce the effective memory access time from 200 nanoseconds to 65 nanoseconds? Look at this. If we don't use the cache memory, effective access time is 200 nanosecond. Means this is given as main memory ka access time. Without cache, 200 nanosecond is required. Now, if you are using the cache memory, then this is the access time. When you use the cache memory, what is the effective access time? Nothing but T average memory access time. If cache memory ka access time is given TCM, then what is the hit rate of cache memory? Is there any word of level or hierarchy mentioned? No. So we will use here what? Simultaneous access again. Let's use simultaneous access. Fine. Okay. If simultaneous access T average is equal to hit नहीं पता कितना into 50 nanoseconds plus miss into 200 nanoseconds. Can you solve this? कितना आएगा? जल्दी से बता दो कितना आएगा. Okay, so it will be 65 is equal to 50H plus 200 minus 200H, which is 150 divided by 150, not 150. H is equal to 135 divided by 150. Which is 0.9 or 90%. This is just the calculus question. After this तो फिर धीरे धीरे आप इक्वेशन सॉल्व कर लोगे, आपको आंसर मिल जाएगा. शुड वी गो नेक्स्ट? क्या आगे बढ़े? This particular session I have kept for 2 hours. In the 2 hours I will try to solve all those GPK question. If any question will be left, either we can extend if very less number of questions will be left, otherwise we will see another session, a small more half an hour session or so I can take, and we will finish all the questions. A computer system contains a cache. Fine, बहुत अच्छी बात है, congratulations system, आपके पास कैश मेमोरी है, हमारे पास नहीं है. Uncached memory access takes 9 times longer than access to cache. Uncached memory means not having cache memory. A memory system which is not having any cache memory. A memory system which is not having cache memory means only main memory is there. So it's very simple statement. Main memory का access time is 9 times of cache memory का access time. If the cache has a hit ratio, fine, 0.8. The ratio of cached memory access time. Cached memory access time means average memory access time जिसमें cache memory लगी हुई है. So ratio they are asking of T average to uncached memory access time means only main memory access time. This is the question. आगे बढ़ते हैं. T average, how do you calculate T average? Is there any mention of simultaneous or hierarchical? No. Hierarchy or level word given? No. So simultaneous access. Let's go with the simultaneous access. 0.8 into cache memory का access time plus 0.2 into main memory का access time. Main memory access time is 90 cm divided by TMM is 90 cm. 9 into 0.2, 1.8 plus 1.8 कितना हो जाएगा? 2.6 divided by 9 will be the ratio. Got it? Understood that? Yes or no? Next. In a 2-level hierarchy, the top level has an access time of 10 nanosecond and the bottom level has an access time of 15 nanosecond. First of all, level hierarchy means hierarchical access. I'll have to use. Top level has access time of 10 nanosecond. Top level memory means the memory system which is closest to CPU. कौन सा memory system CPU के close होता है? Cache or main memory? Of course cache. So this is nothing but cache memory का access time. TCM. And bottom level memory means the memory which is away from the CPU, which is main memory. Hit rate at the top level 90%. If the block size of 16 bytes given, then average memory access time is considered. System uses locality of reference. If system is using locality of reference, then whenever CPU will be accessing the main memory, in any case CPU will be accessing the main memory, then we need to use the block access time from the main memory. Block को access करने के लिए कितना time लगेगा? First of all, memory access time given as 50 nanosecond. That is for 1 byte by default. By default 1 byte 50 nanosecond. Such kind of block is of 16 bytes. So can you tell me the block access time from main memory T block will be how much? 1 byte को access करने का time 50 nanosecond. 16 byte को access करने का time कितना लगेगा? 16 into 50 कितना हो जाएगा? 800 nanoseconds. ठीक है, अभी ब्लॉक एक्सेस टाइम इतना है. देन लेट्स कैलकुलेट दी टी एवरेज. एवरेज मेमोरी एक्सेस टाइम होगा हिट. कितना है हिट? 0.9 टाइम्स हिट. In that case, time is only 10 nanosecond plus when there is a miss, at that time first of all 10 nanosecond required plus 800 nanosecond required. क्यों ये 10 nanosecond ऐड किया? क्योंकि नहीं पता सर। अरे यार सिंपल सी बात है, हायरार्किकल एक्सेस है ना, इसलिए। फाइन, सो दिस बिकम्स 9 प्लस 81, 90 नैनोसेकंड इज द आंसर। होप यू अंडरस्टूड। चलिए आगे बढ़ते हैं। In a two-level memory hierarchy, the cache has an access time 12 nanosecond, main memory access time 120 nanosecond, hit rate 90%. If the block size is 16 byte, then the average memory access time including miss penalty. Miss penalty included means you need to now include the transfer time also. When you are accessing the block from main memory, then that block to be transferred to cache memory also. वो कैश मेमोरी को भी ट्रांसफर होना चाहिए। ओके, नाउ फर्स्ट ऑफ ऑल पहले वापस से टी ब्लॉक कैलकुलेट करते हैं फ्रॉम मेन मेमोरी। हाउ मच टी ब्लॉक विल बी फ्रॉम मेन मेमोरी? फर्स्ट ऑफ ऑल वन मेन मेमोरी एक्सेस इज 120 नैनोसेकंड एंड 16 बाइट का ब्लॉक, सो टी ब्लॉक विल बी 16 into 120 नैनोसेकंड। कैन यू टेल मी हाउ मच इट इज? कैन यू टेल मी हाउ मच इट इज? This much 1920 nanosecond is T block. Now the scenario is little bit change. Abhi in this one we have accessed cache for just checking out hit miss. After that we have accessed main memory for block. Now apart from these two time, here in the next question I will have to add another cache memory access time, so that whatever the block we are accessing from मेन मेमोरी दैट कैन बी कॉपीड इनटू कैश मेमोरी। ठीक है, चलिए आगे बढ़ते हैं। सो टी एवरेज will be equal to here when there is a hit 0.9 times only cache memory is accessed, which is 12 nanosecond plus. When there is miss, how much time required? First of all 12 nanosecond for checking hit miss. After that T block for accessing block from main memory plus another main memory access time, another cache memory access time to bring that block into cache memory, to write that block into cache memory. इस इक्वेशन को सॉल्व करें, कितना आएगा? 1920 प्लस 24 इंटू 0.1, 194। 10.8 plus 194.4, it becomes how much? It becomes how much? तुम ही बताओ रे बाबा। 205.2 nanosecond। सॉल्व करो इक्वेशन को, यू विल गेट इजीली द करेक्ट आंसर। सो ऑल दीज क्वेश्चंस are having simple straightforward approach which we have discussed in the classroom. Based on those only I have given all these questions so that you can have a practice and understanding कि कब कौन सा formula use करना है और क्यों. Here I have added another cache memory access time. Why? Just because they have given in the question एक block को main memory से cache memory में लेके आना पड़ेगा when there is a miss. लेके आ जाएंगे, ठीक है। अब आपके दिमाग भूख को तो यहाँ लेके आओ, दिमाग को भी तो वापस लेके आओ यहाँ पे, कि नहीं लाओगे? नहीं सर, वो फिर सो रहा है, सोने दो उसको। क्या जागो मोहन प्यारे। अब मेमोरी एक्सेस टाइम इज 1 nanosecond. दिस इज अ गेट क्वेश्चन, वेरी वेरी गुड क्वेश्चन। Okay, so the things are given: 1 nanosecond read operation hit, 5 nanosecond read operation miss, 2 nanosecond write operation hit, 10 nanosecond write operation miss. Execution of sequence involves 100 instruction fetch from memory, then 60 memory operand read from memory, and 40 memory operand write to memory. If hit ratio is this, average memory access time is how much? We know that average memory access time is percentage of read into T average plus percentage of write into T average write. Percentage of write into T average write. In this particular question, we need to calculate T average read and T average write separately. चलिए, तो पहले एक काम करते हैं. We will see how much T average read we have. T average read. So hit ratio given is 90%, which is 0.9 into what is the hit time when there is a read? Read hit time is 1 plus when there is a miss for read 5 nanosecond is required. This is T average read 1.4 nanosecond. Similarly, let's calculate T average write also. How much average access time for memory when there is a write operation? So hit ratio is again same 0.9 into, now the time for write is different, 2 nanosecond for write operation when there is a hit. So 2 nanosecond for hit for write, and when there is a miss 10 nanosecond for miss for write. It is given in the question. ये देखो लिखा है. It will become 2.8 nanosecond. So T average read write I have calculated. Now I'll have to calculate among total memory operations how many percentage of operations are for read and how many percentage of operations for write. So let's see how many times CPU is trying to access the memory. ये रहा. Sequence of instructions involve 100 instruction fetch operation. What is instruction fetch operation? Instruction fetch is nothing but going to the memory, getting the instruction from memory, and that is read. Memory read operation hai. So how many read for instruction? 40. Then how many read for operand? 60. Total how many read? 160. And how many write? 40. So total number of operations are how many? 160 plus 40, 200. 200 total operation. Among those, read are how many? Read are 160 among 200, which is 80% or 0.8. And write are how many? Remaining 40% या 20%? 20%. Remaining 20%. 40 divided by 200, total 20% or 0.2 in fraction. Use these informations, put here and get the answer. So 80% time T average read is required, which is 1.4 nanosecond, plus 20% time T average write is required, which is 2.8 nanosecond. Total you will be getting as 1.68 nanosecond. That is the average memory access time. This was one of the really good question of GATE 2014. In 2014, they have asked 2-3 questions in such a way. Those were really amazing, very tricky, very what should I say, time consuming for you if you don't understand how to solve such questions. चलिए आगे बढ़ते हैं. Consider a direct mapped cache of size 64 kilobyte. Consider कर लिया, ठीक है. CPU generates 32-bit address. Fine. The number of tag bits in the main memory address are. This is one of the very easy question. Why? We know that in the direct mapping we divide this 32-bit ka main memory address. Why this 32-bit ka? Just because given in the question memory address is of 32 bits into 3 parts: tag, then line number or block number, cache memory ka block number, and byte offset. If you know this particular thing or not, convert this cache memory ka size into 2 power. How much it is? 2 power 16 bytes. 2 power 6 is 64, k is 2 power 10. So if you know that, then you should know this, that these two fields, block number and byte offset, will be log of cache size base 2. Log of 2 power 16 base 2 means 16 bits. These two fields will be of 16 bits. If these two fields will be of 16 bits, remaining tag will be of 32 minus 16, 16 bits. Like this way you can solve. Praveen Singh has even given the answer also. That's amazing. Superb. I know you guys have gone with this particular playlist very rigorously, very sincerely, just because you knew that this particular playlist has given you a lot, and hence I have given you some practice questions for the same reason, that you can have some more practice and you can understand the concept even in more detail. That's really good that you got the answer also. This is another gate question which I have given you as a DPP question. Fine. Let's read. 8 kilobyte direct mapped write back cache is organized as multiple blocks, block size 32 bytes. The processor generates 32-bit address. So main memory address is 32 bits. Fine. This is the main memory address, 32 bits. We know that in the direct mapping we divide main memory address into 3 parts. What are the 3 parts? अभी तो बताया थोड़ी देर पहले. Tag, then cache memory का block number and byte number, byte offset, right? चलिए आगे बढ़ते हैं. 32-bit main memory address is given. Fine. What is given in the question? The cache controller maintains the tag information for each cache block comprising following: 1 valid bit, 1 modified bit, as many bits as minimum needed to identify the memory block mapped in cache. कौन सा मेमोरी ब्लॉक कैश मेमोरी में रखा हुआ है, इसकी इंफॉर्मेशन कैसे मिलती है? इसकी इंफॉर्मेशन मिलती है टैग से. So this is nothing but tag information given. What is the total size of memory needed at the cache controller to store metadata? We know the formula of metadata, right? Metadata का size कितना होता है? Number of blocks in cache into tag bits plus extra bits. That is the formula for metadata. Tag bits I don't know, number of blocks I don't know, extra bits given 2 bits. Let's calculate the tag and number of blocks in cache. First of all, 32 byte का block size is given, hence byte offset is 5 bits. We know that this is 8 kilobyte. 8 kilobyte is 2 power 13 bytes. Means this particular entire two fields will be of 13 bits. देखिए यहाँ पे अब आपको मैं शॉर्टकट फॉर्मूला बता रहा हूँ ताकि आपको जल्दी से क्वेश्चन सॉल्व हो जाए. यू विल नॉट हैव टू डिवाइड द थिंग्स कि नंबर ऑफ ब्लॉक्स निकालने के लिए कैश साइज डिवाइड बाय ब्लॉक साइज करेंगे एंड सो ऑन. टोटल 13 बिट्स, अमंग दोस 5 बिट्स गॉन हियर मींस 8 bits here. 2 power 8 should be the number of blocks. Definitely. Remaining tag bits, 32 minus 13. कितनी बची tag bits? 19 bits. So what should be the values here? Metadata size, number of blocks in cache 2 power 8, 8 bit के according, into tag bits 19 plus extra bits, 1 valid and 1 modified, 2 bits. 2 power 8 to 56 into 21, you will get 5376 number of bits. That is your answer for this particular question. सो गए क्या सब लोग? जाग रहे हो? जाग रहे हो या सो गए? ठंडी बहुत ज्यादा है सर, टाइप करने का मन नहीं करता. एग्जाम में ऐसा मत कर देना रे सर, ठंडी बहुत ज्यादा थी, हम क्लिक नहीं करके आए, आंसर तो सब कर दिए थे. फिर एमटेक वाले आईआईटी वाले बोलेंगे ठंडी बहुत ज्यादा है, हम तुमको इस बार एडमिशन नहीं दे रहे, हम लिंक पे क्लिक नहीं कर पा रहे. चलिए अनदर क्वेश्चन. अ साइज ऑफ फिजिकल एड्रेस स्पेस ऑफ अ प्रोसेसर इज 2 power p bytes. Okay, physical address space is nothing but main memory का size 2 power p bytes. If main memory का size is 2 power p bytes, from here you can calculate main memory address. Main memory address will be of just p bits. Further, the word length is 2 power w bytes. The capacity of cache memory is 2 power n bytes. The size of each cache block is 2 power m words. And for a k-way set associative cache, the length of tag field is how much? This particular question again you can solve with the tricks or the shortcut method which we have discussed in the classroom. Look at this first. First of all, we divide the main memory address of p bits into 3 parts. How can I say main memory address of p bits? अभी तो थोड़ी देर पहले वो बताया लाल लाल अक्षरों में, ये देखो 3 parts. What is this? It is a set associative mapping, so the 3 parts will be tag field, and here will be set offset and byte offset. Now as we know that these two fields, number of bits will be log of cache का size minus log of associativity. What is the associativity? K-way set associative, that's why K. What is the cache size given? 2 power n. If log of 2 power n you will calculate, that will become n minus log of k. If n minus log of k bits in this one, then tag will be how much? Tag will be p minus n minus log of k. Minus to minus plus, it becomes p plus p minus n plus log of k. Which option is matching? कौन सा ऑप्शन मैच हो रहा है? Which option is matching? B. Now look at this. When I was solving this question in GATE 2018, yes, it's a GATE 2018 question and I have written that exam. 440 was my rank in this paper. When I was writing this paper, I was going through this question. I have drawn this much. I understood p minus n minus log of k will be answer and I was going with option A. फिर मैंने सोचा लिख लेता हूँ एक बार. Let's see, write down. So p minus n minus log k I tried to write. In that particular case, I understood that I'll have to keep this n minus log k in single bracket. Entire thing I'll have to subtract. In that case, log k will become plus. So when I have written it, I got to know that yes, I was missing this small thing, and that is nothing but the silly mistake you may have in the exam. So always try to write down which you want to solve. If you are confirmed with some answer, such kind of small mistakes you may commit in the exam, and that is the lack of concentration. You are too much into question and its procedure that you don't understand such kind of small things, or you don't concentrate on such kind of small things, and which can make a lot of difference in your rank. Try to write down such kind of things, small points, और जल्दी से solve करके और आंसर टिक करिएगा करेक्ट वाला. Definitely you will get a correct answer. Nice. Next one. If the cache contains 2 power 16 number of blocks, main memory contains 2 power 24 number of blocks, then the size of cache tag directory for a fully associative cache is what? For the fully associative cache, for fully associative cache, if you know this, well and good. If you don't know this, then remember the tag is nothing but main memory का block number. Yes, the main memory's block number is the tag bits. So if number of blocks are 2 power 24 in the main memory, can you tell me main memory block numbering of how many bits? 24 bits. So here in the fully associative mapping, 24 bits will be of tag. Now the question becomes very simple. Tag directory size is equal to number of blocks in cache into tag bits plus extra bits. Tag directory size is equal to 2 power 16 number of blocks in cache. For each block we are maintaining 24 bits of tag plus extra bits, nothing given in the question, so ignore कर दो. 2 power 16 into 3 bytes. Convert this into kilobyte and you will get the answer. Got it? Check out. क्या ये ठीक है? Understood, not understood, keep talking, keep working along with me. Definitely you will learn a lot. मेरे क्वेश्चन सॉल्व करने से आप ज्यादा नहीं सीख पाएंगे, आपको भी क्वेश्चन सॉल्व करना पड़ेंगे, तभी मिलेगी रैंक. और उसके लिए एक सिंपल सी बात है, साथ साथ में सॉल्व करो, मजे करो और सीखो. चलिए अनदर क्वेश्चन. मेन मेमोरी एड्रेस 36 बिट्स, cache size 256 kilobyte, block size 64 byte, number of tag bits in direct mapping, 4-way set associative mapping and fully associative mapping. ओके फाइन, कर देंगे, कर दवांगा, ये भी कर दवांगा. चलो ई ले. दिस इज डायरेक्ट मैपिंग, सेट एसोसिएटिव मैपिंग, फुल्ली एसोसिएटिव मैपिंग. वी डिवाइड द एड्रेसेस इनटू 3 पार्ट्स इन डायरेक्ट मैपिंग, which are the tag, cache memory block number and byte offset. In the fully associative mapping, okay, that's later, set associative mapping, it will be tag, set offset and byte offset. In the fully associative mapping, it's just the tag and byte offset. Okay, look at this. First of all, fully associative mapping. Fully associative mapping, memory address 36 bits. Among those 36 bits, offset will be of how many bits? Based on the block size, 64 byte, which is 6 bits. So how many tag bits? 36 minus 6, 30 bits for tag. Direct mapping. In the direct mapping, the memory address given is of 36 bits. Cache size, okay, this is 6 bits. Cache size is 256 kilobyte. 256 kilobyte is 2 power 18 bytes. So these two fields should be of 18. Among those 6, offset 12 bits for cache memory ka block. Right? So tag bits will be how many? 18 bits. In the 4-way set associative mapping, the entire 36 bit will be divided into 3 parts, 6 bits. Here these two fields will be log of cache size, which is 18 minus log of 4, which is 2, 16. So sets will be 2 power 10, 10 bits for set offset, 16 gone. Here tag will be of 20 bits. So answer will be 18, 20 and 30 bits respectively for tag in 3 different mappings. This is the answer for the question. Check out if you are still confused with something. If you did not get anything, just let me know so that we can go with the understanding. ओके, चलिए आगे बढ़ते हैं. ये रहो आपका अगला प्रश्न, बहुत बहुत आसान है. दिस इज अ पर्टिकुलर क्वेश्चन ऑफ गेट. What it says? A direct mapped cache with 8 blocks 0 to 7 in there. Okay, if the memory blocks are requested in following order, first of all request of 3, then 5, then 2, then 8 and so on, which one of the following memory blocks will not be in the cache at the end of the sequence? Once the sequence is done, then which block will not be there in the memory? Fine, chaliye. So let's draw first the memory. Okay, I have drawn the memory. The cache memory is having 8 blocks. How many blocks? 8. 0, 1, 2 3 4 ओ ज्यादा दूर हो गए, नजदीक कर देते हैं, 0. Let me take the line, that will be better idea. 0 1 2 3 4 5 6 and 7. 0 1 2 3 4 5 6 and 7. If you know the mapping constraint, well and good. If you don't know what is the mapping constraint in the direct mapping, I can tell you. If you want to know the cache memory ka block number, that any main memory block maps to which cache memory block number, then do one thing. Whatever the main memory block number given, take the modulus by number of blocks in cache. Number of blocks, how many in the cache? 8 here in this question. Okay, so let's do this. 3 mod 8 3, so 3 will keep here. 5 mod 8 5 at 5. 2 mod 8 2 2 पे रख दिया. 8 mod 8 0 0 पे रख दिया. 0 mod 8 0, but at one block you can keep only one block. Yes, so it is already there 8. क्या करें इसको रिप्लेस करेंगे एंड 0 को लेके आएंगे. 63 at 7. 63 mod 8 is 7. 9 mod 8 1. 20 mod 8 4. 16 plus 4 17 is at 1. 9 will be replaced by 17. 25 at 1 only, so 17 will be replaced by 25. 18 will be on 2. 2 replaced by 18. 30 at 6. 24 plus 6. 24 at 0. 0 will be replaced by 24. Then 2 will be replacing 18. 63 hit, 5 hit, 82 should be at 2. Then 17 at 1, 25 will be replaced by 17. 24 already there hit. So which is not in the cache? 3 is there in the cache? Yes. 18 is there in the cache? No. 20 is there in the cache? Yes. 30 is there in the cache? Yes. 18 is not present. 18 is not present. Key correct answer is B. Good Golu. Nice. Nice. Another question. Two-way set associative cache with LRU cache replacement contains 8 number of blocks. The cache request for main memory blocks is this order. Find the number of miss, number of hits, number of hit ratio, miss ratio, number of cold capacity and conflict miss. If 8 number of blocks are there, two-way set associative, can you calculate how many number of sets should be there in the cache? Number of sets कितने होने चाहिए? Number of sets is equal to number of blocks divided by associativity 2. Answer is 4 sets. So 4 sets. Okay, fine. Let's draw these 4 sets here. Each set can contain 2 blocks. So I am organizing the cache in two-way associative manner. 0, 1, 2 and 3. This is the cache organization I have drawn. So this is cache memory. Set number 0, 1, 2 and 3. Fine. Let's try to solve this question. First of all, access of 8 modulus. By now in this associative mapping we need to take the modulus by number of sets. Number of sets are how many? 4. So 8 modulus 4. 8 mod 4 is 0. 8 should be kept at 0. But is this the first time access? Yes, this is the first time access, means it's a miss. Or what type of miss? Cold miss. Now 12, is this the first time access? Yes, miss होगा. Yes, cold miss. 12 mod 4 0, तो 12 को भी 0 पे रख देंगे 8 के साथ में. Then 0 mod 4 0, this is the first time access. Yes, so again a cold miss, and 0 also will be placed on 0 only. 8 and 12 already there, we need to replace one. Which one? Based on LRU policy we need to replace which one? LRU policy के according recently referenced 12 we will keep and 0 will be replaced. Next is 1. 1 is requested. 1 is requested first time. Yes, so cold miss. Cold miss, 1 will be placed at 1. Next one, 5. 5 is the first time requested, yes, so cold miss. 5 mod 4 should be kept at 1, so 5 also kept at 1. 8 not present, no, miss. Is this the first time access of 8? No, पहले access हो चुका है, yes, means it's not a cold miss. Let's check out if cache memory is full. No, cache memory is not full, hence it's a conflict type of miss. 8 should be kept at 0, yes. अब 0 में 0 ब्लॉक पे कौन सा ब्लॉक रखेंगे, 0 सेट पे कौन सा ब्लॉक रखेंगे, 0 will be kept, 12 will be replaced. Why? Just because LRU policy least recently used 12 is replaced by 8. Now 1 hit, 12 miss, conflict miss. Why? Just because 12 got referred before, yes. This time again got referred, but it was having a miss. Why? Just because for 8 we have replaced 12, so conflict miss, and 12 will be brought for what? 0 को replace करके लेके आएंगे, just because 8 just got referred now only. Now for 3 will be kept at 3, cold miss, first time access. 9 should be kept at 1, cold miss. Why? Just because first time access of 9, so 9 will be placed at 1, but on the set 1 we have referred 1 here, so we will have to replace 5 by 9. Next is 6, first time access of 6, yes, so it's a cold miss again. 6 will be placed at 2. Then 7, first time access, yes, so cold miss again. 7 should be placed at 3, 7 mod 4 is 3. Then 2, first time access of 2, yes, cold miss, and 2 will be placed at 2. Next 15 mod 4 3, and 15 is the first time access, yes, so it's a cold miss again. Where should I keep it? 15 3 पे तो 2 already set पे block हैं, 3 and 7, which should be replaced? 7 just recently referred, 3 referred here, so 3 will be replaced by 15. Next is 16 first time accessed, yes, कितने cold miss आएंगे? Oh, this is also cold miss. Now if this is also cold miss, I'll have to check if this, I'll have to keep where? At 0. At 0, what you have referred last? 12. You have referred 8 before that, so 8 should be replaced by 16. Next is 11. First time access of 11. Yes, cold miss. Where should I place this? 11. 11 modulus 4 is 3. So on 3, I have just referred 15. 7 should be replaced by this 11. 14 first time accessed. Yes, again cold miss. 14 mod 4 is 2. I'll have to keep it at 2. 2 यहाँ refer हुआ है, 6 यहाँ refer हुआ है. Among these, 6 will be replaced by 14. Then 9, it's a hit. 10 not present, no, it's a miss. Is this the first time access of 10? Yes, cold miss. Where should I keep 10? At 2. At 2, 14 will be there, 2 will be replaced by 10. Now just calculate how many number of misses. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 and 17 total misses. So number of miss is equal to 17. How many number of hits? 1 here and 1 here, only 2. So what is the hit ratio? Among total 19 accesses, 2 only hit among 19 and 17 miss among 19. How many cold misses can you calculate? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 and 15 cold misses. How many capacity misses? No any capacity miss, 0. And how many conflict misses? Of course 2, 17 misses, 15 cold miss and 2 conflict miss. What is the cold miss? First time access. What is the capacity miss? When not first time access and cache memory is full, then capacity miss. If it's not full cache memory, not full, and the miss is not the cold miss, then definitely it will be a conflict miss. This is the theory we all know, we have applied, and we got the answer. चलिए आगे बढ़ते हैं. Another question. This is another gate question. Very simple it is. I guess gate 2019 or 20 question it is. Certain processor deploys a single level cache. Fine. The cache block size is 8 words and the word size is 4 bytes. Means 32 bytes का block size. 8 into 4. The memory system uses 60 megahertz clock. Fine. A service a cache miss. To service a cache miss, the memory controller first takes one cycle to accept the starting address of the block. तो एक miss को service करने के लिए memory controller first takes one cycle to accept the starting address of the block. Okay, it then takes 3 cycles to fetch all 8 words of the block and then finally transmits a word, the words of requested block at 1 word per cycle. 8 word को 1 by 1 एक cycle में एक word transmit कर देता है. The maximum bandwidth for memory system when the program running on the processor issues a series of read operation is how much? First of all, to calculate the bandwidth in bytes per second or something, I'll have to calculate the time, that how much time that memory will take for that given scenario. So the memory takes time to transfer one block. The information is given for one block, right? To transfer one block is equal to how much? Is equal to, first of all, one cycle for accepting the address plus 3 cycles to fetch 8 words, all 8 words 3 cycle plus transmission के लिए 1 word per cycle. How many words are there? 8 words. So 8 total cycles, total 12 cycles are needed for accessing entire block from main memory. Entire block will be accessed in how much? 12 cycles. Now what is 1 cycle time? From here you can calculate. Yes, so 12 cycle will be equal to 12 into 1 divided by 60 megahertz time, which is nothing but 12 by 60. Can I say 1 by 5? 1 by 5, mega will go up, becomes micro, hertz will go up, becomes second, microsecond. So 1 by 5 microsecond that memory takes to transfer one block, and this one block of how much size? One block of 32 bytes. 32 bytes. Why I am writing 32 bytes? Just because 8 words are of 32 bytes and they want answer us to be given in 30 bytes only. So for 32 bytes this much time. Okay, so what is the question? In 1 second time how many bytes you can transfer? Okay, let's calculate that. In 1 by 5 microsecond the data is transferred is equal to 32 bytes. Hence, in 1 microsecond, the transfer data is equal to 32 into 5, which is equal to 160 bytes. अब ये तो हो गया 160 bytes per microsecond. I'll have to calculate in second, per second. Okay, fine. So in 1 second, the transfer data is equal to 160 bytes. सेकेंड को कन्वर्ट करो और माइक्रोसेकेंड को कन्वर्ट करो सेकेंड में, दिस बिकम्स 10 to the power minus 6 second, which is nothing but 160 into 10 to the power 6 bytes per second. So answer should be 160 into 10 to the power 6 bytes per second is the answer for this question. Got it? Understood that? Okay, another question. So this particular question is of magnetic disk. Let's solve this particular question. Consider a disk with an average seek time of 4 millisecond. Fine. So seek time given 4 millisecond. Rotational delay of 2 millisecond. Already given. Rotational delay, rotational latency given directly 2 millisecond. Rotation speed 15,000 rpm. Based on rpm you can calculate rotation delay, but still they have directly given 512 bytes per sector with 500 sectors per track. Some informations given. A file occupies all of the sectors on 5 adjacent track. एक फाइल 5 अलग अलग ट्रैक पे स्टोर्ड है. In that particular case, how many tracks I should access to access the file? 5 tracks. On 5 tracks, how many sectors I'll have to access? Each track having 500 sectors means 2500 sectors you are accessing to access the entire file. Fine. After reading the first track, if remaining track can be read with no seek time, एक बार का ही सीक टाइम लगेगा, बचे हुए ट्रैक के लिए सीक टाइम नहीं लगेगा, ऐसा क्वेश्चन में मेंशन है. देन टाइम रिक्वायर्ड टू सीक्वेंशियल ऑर्गेनाइजेशन ऑफ ट्रांसफर ऑफ द फाइल विल बी नियरली हाउ मच? First of all, I know that total time will be equal to seek time. Only one time required seek time? Yes. Plus, if seek time is required one time, fine. But how many tracks I'll have to transfer? 5 tracks. अगर 5 ट्रैक ट्रांसफर करने हैं तो 5 टाइम्स रोटेशन डिले तो लगेगा. So rotational delay is 5 times plus transfer time. How many tracks you are transferring? 5. Among those 5 tracks, how many sectors you are transferring? 2500 sectors you are transferring. So 2500 into 1 sector transfer time. 1 sector transfer time. Now, how much is 1 sector transfer time? How much is 1 sector transfer time? That you will have to calculate. So, let's keep the value. Seek time 4 millisecond plus 5 times rotational delay 2 millisecond plus 2500 into 1 sector का transfer time. 1 sector transfer time depends on 1 rotational delay. So here, from here 15,000 rpm I'll have to transfer, I'll have to calculate the rotational delay or 1 rotation का time. So let's calculate 1 rotation time. Let's calculate 1 rotation time. 1 rotation का time is equal to, for 1 rotation, how much time? 60 second is for 15,000. So 60 second divided by 15,000 is the seconds rotation time given. But I'll have to calculate this in millisecond. Why? Other values are also given in millisecond. That's why into 1000 it becomes 4 millisecond. 1 rotation में 4 मिलीसेकेंड में यू कैन ट्रांसफर 1 सेक्टर, देन और सॉरी 1 ट्रैक, 1 कंप्लीट ट्रैक you can transfer in how much time? In 4 millisecond, which is 1 rotation time. So 1 sector transfer time is how much? If 500 sectors are there in 1 track, so 1 sector transfer time is 1 rotation का time, which is 4 millisecond divided by number of sectors 500. One number of sectors per track 500. Okay, let's keep that value here. Let's keep that value here. 4 by 500 milliseconds. So it becomes 4 plus 10 plus 20 millisecond, total 34 millisecond. Answer is asked in the seconds. Divide this by 1000, this becomes 0.034 millisecond. Answer is this one, sorry, not millisecond, second. Sure. Okay, fine. So this question is done. Okay, fine. Now there are few questions remaining, but those questions we will be doing in another session, just because we have another session lined up 10:30 p.m. or sorry 10:30 a.m. So I'll have to close this particular session now. Only a few questions left. Only a few questions left. Those questions we can do in another session. So thank you so much for joining. Okay, पहले आप कुछ और information ले लो. यहाँ पे look at this. You all know that a legendary educator is joining us very soon. Just 2 days left. On 15th of December 6 p.m. on Unacademy Computer Science channel, we are launching a new legend educator. You will have to come live to see who is coming, and just check out that who is the legend who is going to join us here 15th December 6 p.m. This is my team. This particular team is having 3 more educators, not visible here, but 3 more educators we have included in our team, and those all educators are teaching you live, plus all these playlists are available in your YouTube. This particular channel as a complete package: discrete math completed, COA completed, machine learning completed, operating system, theory of computation, and computer network. All these are completed. In fact, my data structure is already going on, which also will be completed in very few days. All these are the complete playlist. Go and check out. You will learn a lot from these. बहुत सारे अच्छे प्लेलिस्ट हैं आपके पास. ओके, इफ यू वांट ऑल दीज पीडीएफ जो अभी मैंने सॉल्व किया है, इसका अगर आपको पीडीएफ चाहिए विद रिमेनिंग क्वेश्चन ऑल्सो, देन यू जस्ट गो ऑन दिस पर्टिकुलर टेलीग्राम चैनल. इमीडिएटली आफ्टर द क्लासरूम आई विल ड्रॉप माई पीडीएफ ओवर देयर, डाउनलोड एंड गेट रिमेनिंग क्वेश्चंस ऑल्सो, so that you can solve those questions along with me in the next session. Okay, and if you want to be connected with us, be connected with us on these Facebook pages. This is the page where we are connected with you all. If you have friends in other domain, including your mechanical, in electrical, electronics, instrumentation, civil, if you have friends who are preparing for RRB, SSC, or anything, you need to recommend them our family channel. Our family channel means we have a large family of the engineers, top educators who are teaching you all in different domains. We have the channel for electrical, ECIN, Creatrix channel. We have for mechanical, ME channel, Gate ME API XC channel. We have for civil this particular channel. Recommend your friends to go through these channels. If you have friends in Telugu speaking language, then let them know there is a channel over there. The educators are teaching in Telugu language. Unacademy Computer Science channel, your own channel. If you have friends in computer science, then please let them know that this is the channel over where we are providing lot of free content in terms of quality education. So everybody should get the chance to learn for free, plus learn more in more quality. If you haven't liked the session, please like kar do. Every time you watch the session, whether you watch it live or you watch it in recorded mode, like the video every time. Share the lectures, playlist, and this particular channel with all of your friends. Subscribe the channel if you haven't till now. Notification you make turn on, so that you will get the notification of each and every time, each and every class, whenever we'll be having the classes for you. Happy learning, people. Keep learning happily. We will meet you soon. Remember, 10 p.m. I am having very special session. That particular special session is about why only covering the syllabus is not enough to get the top rank in GATE. That particular session is gonna be very informative for all of you. Join that particular session 10 p.m. and till then, see you soon. Have a nice remaining day. Thank you. Bye.